Okay, so today we are going to be reviewing skills we've already seen in order to prepare you for your test. So we're going to start with our operations and just going over some reminders. So some reminders about multiplication and division. One of the biggest reminders about multiplication and division is that our overall goal is to factor and simplify. Simplifying is canceling those common factors. So when we're multiplying, sometimes it's a little confusing because we're not actually going to do any multiplication. We're not going to make it any bigger. Our whole goal is to actually factor and cancel. And the other reminder that we need is that for division, there is a step 0, which we call keep, change, flip, which is the same thing as saying multiply by the reciprocal. So multiplying and dividing, our biggest goal is actually just to simplify. So we're going to factor the numerator and the denominator and cancel those common factors. And then remember for division, we do have that step 0, which is to multiply by the reciprocal, so keep, change, flip. Once we've done that, we're in a multiplication problem. Let's look at adding and subtracting. When we're adding and subtracting, one of our big things here, one of our big reminders, is that we need a common denominator. We get that by multiplying one or both of the original fractions by a well-chosen one. And remember, a well-chosen one would be something like x over x plus 3 over x plus 3, x minus 2 over x minus 2. All of these are examples of, well, they're all examples of ones. The well-chosen one will give me the correct common denominator that I'm looking for. The other big reminder with adding and subtraction, I'm going to change colors because it's for subtraction. So when you have a negative, so for subtraction, when you have a negative, you must distribute it to every term in the numerator behind it. And so it always goes to what's immediately behind it, and it only goes to the numerator. So it change every sign there. So with these being our overall reminders of what to do with operations, let's go ahead and look at some examples. So the first thing I'm going to do here, I see immediately off the bat, it's division. So I'm ready to do my keep, change, flip. That means this first fraction stays exactly the same. I keep it. I change my division to multiplication. And I flip my second fraction. So its numerator becomes its denominator and vice versa. We get it flipped. Now, like I said, our biggest goal here is to factor and cancel. So I have 4 things to factor: numerator 1, numerator 2, denominator 1, denominator 2. Each of those needs to be factored. So as I look at this first numerator, I notice they're both divisible by 10, and they both have at least one x. I'm going to bring those out to the front. That leaves me with x plus 2. And the denominator then, I'm going to factor out a 2 because they're both even, and that leaves me with x minus 2. At this stage, I have sometimes put the multiplication symbol here so you can see where I stopped, but multiplication really just means we can extend this bar all the way out. We're just multiplying things. So as I look at this one, I'm going to say, you know what, they both have at least an x squared, so I can factor that out. That leaves me with that x minus 2. And in the denominator, they're both divisible by 5, so I'm going to factor out that 5, and that leaves me with x plus 2. Now, some of you may want to be even more particular, and this 10 come in and say that 10 is really 5 times 2. That helps us see some of the factors on the bottom. So now that we've fully factored, we can go ahead and cancel any common factors that we see. Having split 10 up, I see that there's a 5 on the top and the bottom. There's a 2 on the top and the bottom. There's an x plus 2 on the top and the bottom. And there's an x minus 2 on the top and bottom. So I factored it. I canceled everything that was there. Now, my final answer is just what is left over. Well, I notice that I have an x times x squared left over, so my final answer here would be x cubed. And that is division of rationals. Keep, change, flip. So this one stayed the same. Change to multiplication. This one got flipped. Factor. And then any common factor you have in the numerator and the denominator, go ahead and cancel it out. And your answer is simply what is left over. All right, let's look at addition now. So we said for addition, we need a common denominator. What we really mean by that, a common denominator, is that their denominators need to have the same factors. That's what we're doing when we're finding a common denominator. So in order to do that for this problem, the first thing I need to do is actually factor the denominator so I know what do they have in common and what do they not have in common. So here, right off the bat, we can compare their denominators. Once again, the way we can factor this really quickly is what numbers add to give me 1 but multiply to give me negative 12? Well, 4 and negative 3. 4 times negative 3 was negative 12. 4 plus negative 3 is positive 1. Over here, 1 times 4 is 4. 1 plus 4 is 5. So now we're going to look. Our goal is once again to get that common denominator. So I notice that they both already have x plus 4. That's great. We don't need to do anything with the x plus 4. It just stays where it is. But this one has an x minus 3, and this one has an x plus 1. So what we need to do is then give those to each other. So my first one has an x minus 3, but in order for them to have the same factors, the second one needs it as well. And vice versa, this one has an x plus 1. In order for them to be perfectly identical, this one needs it as well. This is what we mean by that well-chosen one. We're giving that other factor to the other fraction by writing it as a well-chosen one. We're going to multiply in both the numerator and the denominator. Now this is a big step. Here's my order of operations. Our goal is to actually add, but before I can get there, we know that these go in order, I must actually do my multiplication. So before I can get to my adding step, I want to add, before I can do that, I must actually multiply these out. And you can notice from my arrows that I'm making sure to distribute to each term. Now I do have a common denominator, and since I do have a common denominator, I can go ahead and combine like terms. So I have x squared and x squared, that gives me 2x squared. Negative 2x and positive x gives me negative x, and negative 3x, those add to give me negative 4x, and then I just have a negative 2 left. Our last step here is always to see, can we factor further in order to cancel? I want to know, does 2x squared minus 4x minus 2, is it made up of x plus 1, x plus 4, or x minus 2? If it is made up of any of these, we would cancel them out. So looking, I'm going to see, well, they're all divisible by 2, so I can bring that out to the front. Now, doing what I know from factoring, I want to know what two numbers multiply to give me negative 1, but add to give me negative 2. I got this from here and here. Well, the only thing that can multiply to give me negative 1 is 1 times negative 1. But when I add those together, 1 plus negative 1, that gives me 0, which isn't negative 2. So I say this does not factor any further. There are no common factors to cancel. So here we have it, our final answer. So adding and subtracting, you see via the colors, a few more steps. We found what do they have in common, what do they not have in common, and we went ahead and multiplied. So this one did not have an x plus 1, we gave it to it. This one didn't have an x minus 3, so we gave it to it. And this step, using the pink, we said, hey, you actually have to multiply. Moving on to blue, we combined like terms. And then our very last step over here was trying to see, does this factor any further? Can we cancel? And the truth is, we couldn't, so we were done. So that is a quick review of how to do your operation, so multiplying and dividing or adding and subtraction of rational expressions.